Hello, Math 7 students. We are now beginning Module 2, Lesson 13, and in my table of contents, it is called Converting Rational Numbers to Decimals Using Long Division. And this lesson in my comp book can be found on page 71, so I'm going to go ahead and turn there now. So, converting rational numbers to decimals using long division. Okay, rational numbers, really quick. Rational numbers are all numbers that you can find on a number line, right? So they could be in a fraction, they could be a decimal, they could be a whole number, they could be a counting number, they could be all of those numbers. All right, so converting rational numbers to decimals using long division. Your favorite, I'm sure. All right, our goal. Today we will learn how to turn any rational number into a decimal. The question that I want you to be thinking about is, what is a decimal's name if it stops? Don't know if any of you know that. What is a decimal's name if it stops? Okay, so let's look at some stuff that we need to know. Types of decimals. We actually have a couple of different types that we're going to talk about today. The first one that I want to talk about is the terminating decimal. A terminating decimal means that if you take one number and divide it by the other number, that when you find the answer in decimal form, it goes in there exactly, and you have no leftovers at all. So a terminating decimal is a decimal that stops. So for example, if I showed you 2/6, okay? And what this is telling me is I need to take 2 divided by 6. 2 divided by 6. And so I put that in the vinculum, or the house. 2 is the dividend. 6 is the divisor, and we're trying to find the quotient. So we have to ask ourselves the question, how many times does 6 go into 2 evenly? 0 times. How many? Bring up your decimal. How many times does 6 go into 20? 3 times, and we get 18, and then we subtract. And this might not be a good example for terminating, because look at what's going to happen. Are we ever going to stop? So this is not a terminating decimal, because if you notice, it's going to keep going. All right? So this is not terminating. Okay, Mrs. Nelson, think about it. Let's try a terminating. What if I have 1/4? Let's try that one instead. So we're taking 1 divided by 4. Can 4 go into 1 evenly? The answer is no. Okay, can 4 go into 10 evenly? The answer is it can come close. So 2. We're going to do 10 minus 8 is 2. Aha! Bring down the 0. 4 goes into 20 5 times. And boys and girls, here's what I was talking about. There's no leftovers. 0. It stops. We're done. We don't have to keep going. So a terminating decimal is a decimal that stops. It doesn't keep going like this one does. So examples of these are 0 and 25 hundredths, 0 and 5 tenths, 0 and 125 thousandths, 0 and 875 thousandths. Those all stop. They don't repeat. They don't keep going forever. They stop. So a terminating decimal means it's a decimal that stops, just like this one. Okay. Repeating decimal is exactly the one that I made the mistake of showing you first, and a repeating decimal is a decimal that has a digit that repeats forever. So if we go back to 2/6, this decimal repeats forever. It has 3's, and it's going to go forever. It's never, ever, 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 ever going to stop. So 2 divided by 6 is 0 and 33. It's very hard to read this, so you just have to say 0 and 3 repeating is how we say it. We can't even say it's tenths, hundredths, thousandths, because it goes on forever. So the way you read this mathematically, you say 0 and 3 repeating. I know, it sounds weird. Another example of a repeating decimal that you're going to see is you're going to have 0.454545. Mathematically, 0 and 45 repeating forever. So those are repeaters. So those are the types of decimals. We have the terminating decimal that stops, the repeating decimal that repeats forever, and then we have a tool with this because mathematicians had to have a way to describe what's happening because they didn't want to write 3 million repeating 3's. So instead of writing 3 million repeating threes or threes forever or 45s forever, they came up with this tool. And this tool that they came up with is called a repeating bar. And what a repeating bar is it's a symbol used to show the repeating number. So whatever number keeps repeating itself, the bar sits on top of it. Okay? And so let's take that example that we have up here. We have example 0.33333 forever. So instead of having to write 0.3333 forever, you just write 0.3 with the bar above the 3 because the 3 is what keeps repeating. Okay? If you have another repeating decimal that looks like this one, which you will have this, or you could even have a decimal that looks like this, 1453784. Aha, look where it started again. So this, nope, let's say 814. So you notice from here to here is where it will repeat because you have a 1, then you have a 4, so what's going to be the next number? The 3, then the 7, then the 8, and then the 1, and then the 4, and then the 3, and then the 7, and then the 8, and it's going to repeat that whole thing. So we put the repeater bar above the 1, the 4, the 3, the 7, and 8 because that's what keeps repeating. So the repeating bar is a symbol used to show the repeating numbers. So on 0 and 454545, you would put the repeating bar over the 45. If you had this crazy number, it would be 0 and 14378, 14378, 14378. So you would put the repeating bar above the 14378. Okay? So the repeating bar is just a helpful tool for mathematicians so they don't have to write the number over and over and over again. All right, so the bar sits over the number that it repeats. Okay, so I do have some practice problems for you today. I would like you to practice these in your comp book, and then we'll check them in the morning when we get to school. I would like you to practice showing me how to change 4/9 into a decimal using long division, 3/8 into a decimal using long division, and I would like you to show me 2/11 turning into a decimal using long division. And if you have any that repeat, don't forget to put the repeater bar. And if you have any that terminate, which means that they stop, then you will have a complete answer when you do that. Let's go back to our goal for today. Our goal for today was today we will learn how to turn any rational number into a decimal. We did that. We had some examples, and it was kind of fun to do. Question, what is the decimal's name if it stops? Hopefully you can answer that one now because I kind of gave you the answer. All right, my darlings, that's all we have, and I will see you tomorrow. Bye.